All right, guys. Today we're going to be doing a bit of a review of the different methods we have learned to solve systems of equations. So this is a review, practice the methods. And by the methods, I mean the methods that are listed in the table below. And our focus question today is, how do I know what method I should use? So really quick, and pause the video whenever you need to take notes here. Let's see. What are the three ways to solving systems? Okay, so we've already gone over a few of these, so let's start with graphing. Okay, the one thing about solving for graphing is that both of the equations need to be solved for y. This is because when you take your final exam, you will be using Desmos test mode, which only lets you graph something if it's solved for y. So that's the one thing about graphing. However, it can be super convenient because Desmos will just tell you where the solution is. The next method that we have used before is substitution. Okay, the thing about substitution is it's most convenient when you have isolated variables. So for example, x in this equation is isolated. In this case, anywhere where we saw an x in whatever my other equation was, I would use this as a substitute, and hopefully that'll make more sense later when we get to the examples. My final method that we've talked about so far is elimination. With elimination, you want to look for matching coefficients. So for example, I drew an example here. If you have two coefficients that are what I call matching, so like a negative 6y and a positive 6y, this is actually really convenient because when we add the two equations together, we can actually get rid of a variable or eliminate y altogether. So let's do some examples. Like I said, feel free to pause the video at any point if you need to catch up on notes. Also, I will say that the key to these notes is on Canvas if you'd rather watch along with the key. Okay, with so many methods to choose from, it's really important that you try to make your life easy when you choose your best method. Since I see that both of these equations are solved for y, it makes a lot of sense to just go ahead and graph these. So these are solved for y. So our best option is to graph these on Desmos. When you do graph these two equations, y equals negative 2x plus 2 and y equals 3x minus 3, this is the easiest option, especially since Desmos just gives us the answer. So we see that the two lines cross at 1, 0. So that actually is what our answer is, 1, 0, where x is equal to 1 and y is equal to 0. So as we can see, if you are able to graph it, I totally recommend it because it is super quick and easy to solve. Let's see what we can choose for the next example. Okay, for this next example, we're going to choose which method we think is best. First of all, if we wanted to use substitution, we would need an isolated variable. We could make that happen, but it's not looking like too good of a method right now. Elimination is feasible if we were to rearrange these a little bit. But the easiest option here, even though it might not seem that way, is to graph. And yes, that does mean that I'm going to have to solve equation A for y. Okay, so I need to solve this equation for y. I also need to solve equation B for y. Okay, so let's start with equation A. For equation A, all you need to do is subtract 2x from both sides to get rid of that 2x on the left. And we get y equals negative 4 minus 2x. I'm just going to rearrange that because it's not in slope-intercept form. It actually will still graph if you leave it right here, but it's just more proper to write it like this way. And this is my new equation A. I've solved it for y. If we look at equation B, if I want to solve for y, it's just one step. We just have to divide all of my terms by negative 3. And we get y is equal to 2 divided by negative 3, let's call that negative 2/3 x. And then positive 12 divided by negative 3 is negative 4. Okay, so this is my new equation B. Now we're going to take these and graph them on Desmos. Okay, and surprise, surprise, I've already graphed this on my other tab here. So if I plug in these two equations, y equals negative 2x minus 4 and y equals negative 2/3 x minus 4, not a big surprise here since they have the same y-intercept. That makes sense that they would cross there. But they do cross at the point 0, negative 4, where x is equal to 0 and y is equal to negative 4. Okay, let's check out the next example, and hopefully we can see some more variety because we've graphed the first two. Okay, we are on to example 3, and I'm not sure if we're going to get more variety in this example because we have two options here. We could use substitution or we could graph. And before we make that decision, I just want to show you something that can be used to trick you. Equation B is normally, or it should be written like this: y is equal to 3x minus 4. For some reason they wrote it backwards, so that could trip you up. Once you have it the right way around, like this equation B here, graphing starts to look like a better option. Even though we do have that isolated variable, substitution actually does end up taking more steps. I did try it both ways. So I'm just letting you know, actually solving for y tends to be the easiest option. It's the most reliable. However, we have to, if we're going to use graphing, we need to solve for y in equation A. So A is negative 2x plus 5y equals 19. And we are trying to get that y all by itself on that left half of the equal sign. To do that, because I have a negative 2x here, I'm going to add 2x to both sides to get rid of that. We get 5y is equal to 19 plus 2x. We're still trying to solve for y. Okay, the last step I'm going to take here is dividing everything by 5 to get rid of that 5 next to y. We get y is equal to 19 over 5 plus 2 over 5 x. We could write these as decimals and not fractions, but it's not a big deal here in this case. And I'm also just going to go ahead and rewrite this in slope-intercept form just because. Okay, I'll be right back. I'm going to go graph those, and we'll see where they intersect and what my answer is. So I'm comparing equation A, which has now been simplified, and equation B, which is right here. After we graph these two equations on Desmos, we see that they intersect at 3, 5, where x is equal to 3 and y is equal to 5. Okay, sometimes graphing is the best option. I think on the next example, we're going to try something else though. Okay, example number 4, we run into a little bit of predicament. I shouldn't graph this time. I don't think I should graph these. Mostly because I would have to solve both of them for y. It's just not looking like a good option right now. Although it could turn out to not be that bad. I recommend that you try graphing this example on your own. Instead, I'm going to notice that I have some matching variables. I have some matching coefficients here, which means that probably elimination, specifically eliminating y, is my best bet. Okay, so we're going to do this, and to do that, we have to add the equations. Add equations. Okay, this works just like vertical addition if you did that in grade school. Let's see, 18x plus 12x is 30x. Positive 3y plus negative 3y turns out to be 0. So we have done it. We have eliminated y. 3 plus negative 3 is also 0. However, if we get rid of that 0 in the middle, we end up with this equation. You could think about this a couple of ways. You could divide both sides by 30. There are a couple ways to think about this. Just be sure that you know the only number that you can multiply 30 by and get 0 is just 0. Okay, x has to be 0. Also, 0 divided by 30 is just 0, that fraction there. Once we get that, it turns out to be pretty easy to plug this in and get y. And you get to pick whichever equation you want. Since equation A has all positive numbers, I'm going to use that. So instead of x in equation A, I'm going to plug in 0, which is what I just got. Okay, and 18 times 0 is just 0, so we can consider this gone. It's pretty convenient. We get 3y equals 3. If we divide both sides by 3, you're going to get y is equal to 1. That's my solution. If you put those two things together, we can get the coordinate 0, 1. And you could check this by plugging in x equals 0 into either equation. You could try it with b, and it should still be 1 for y when you solve it. Okay, let's see what we got for the next one. Okay, this is going to be our last example for today. And luckily, we're finally about to see the substitution method in action. Okay, so we're actually going to use substitution here, mostly because I see this isolated x. We have x, that isolated variable, is equal to 2y plus 2. I'm going to underline that as well, because this is going to be acting as my substitute. Okay, we're going to take equation A. Let me write it out real quick. We're going to take equation A and replace x with 2y plus 2. Okay, that's all we're going to do. We're going to look at that x and say, okay, I know what x is equal to. It's equal to 2y plus 2. So we're just going to replace it in the equation, and I'll try to color code this accordingly. So we have 2 times 2y plus 2. So there we have it. We just made the replacement right there. Okay, we still have to keep everything else in the equation, and now we're going to solve for y. Okay, because what we have here is an equation with only one variable, y, and we can now solve for y. Okay, it will take a few steps though. First thing I'm going to do is use the distributive property, which tells me that I'm allowed to multiply something on the outside to the inside. Okay, using that property, 2 times 2y is 4y, and 2 times 2 is 4. We're still going to have everything else, just tagging along for the ride for now. The next thing I'm going to do is notice that I have like terms right here. We have a negative 3y and a positive 4y. If you take 4 minus 3, you get 1y. You get 1y. Okay, so that's combining those two green like terms into 1. We're still going to have plus 4, and we're still going to have that equal to 9. I'm going to take my equation up here, so we have y plus 4 is equal to 9. Let's see, if I subtract 4 on both sides, we get y is equal to 5, and that's half my answer. To get the other half of my answer, I'm just going to go up here. To get the other half of my answer, I'm going to use equation B, and I'm going to plug in y equals 5. So we have x is equal to 2 times 5 now, plus 2. Really quick, 2 times 5 is 10, plus 2 is 12. So we get the other half of my coordinate. Oops, make sure to write it the right way, 12, 5. Okay, we get both of my coordinates come together to make that one final solution. Okay, so let's summarize a little bit, and then I'll tell you what you're supposed to be doing for the rest of today. Okay, so just to summarize what we need to be doing today, it is asynchronous today, but I still have to take attendance. I am taking attendance through Canvas, specifically through Warmup 4-4. Hopefully you can head over and complete that warm-up now if you watch the video first. Also, be aware that you do have a new Delta Math assignment today. Since we're so close to the final exam and I won't see you guys that much before the exam, it's important that you practice, especially with these different methods that you may be unfamiliar with. I was pretty lenient with the due date though, so hopefully you appreciate that I made this due Friday at midnight. It is 8 problems, however. Let's see. Also, because I had a low turnout, late credit is available for the last Delta Math assignment. It is 5 problems. I'm closing that assignment Wednesday at midnight. And I also just want to finish by saying the Topic 3 retest is still available. So if that's how you want to spend your time asynchronously, is trying to get your grades up and taking that retest, by all means, feel free to do so. That is closing after this week as well as we head into finals. I do miss you guys today. I hope you enjoy. I hope this video doesn't turn out to be too long. I tried to make it short. Like I said, feel free to go back and pause at any place to make sure you take notes. And if you need anything, send me a message on Canvas. I hope you guys have a good day. And I will see you on Monday next week.